Hello everybody, thanks for coming into science. It's the last period of the day. I apologize for not being here. I am called away on family emergencies. The guest teacher, I also want to thank you for coming in and covering the class. Everything that is going to occur in this class can be found in this video, including the agenda and so on and so forth. If at any point in time you need to pause the video or go back, by all means please do so. I will make some outlined areas where I'd like you to pause the video, so be ready to hit pause. Alright, so folks, you guys, when you came in, there was an article right there on the side of the desk, right when you walked in the door. Please do take that article and go ahead and read it. I'm thinking no more than 3-4 minutes should get you enough time to read it. And the biggest way to find success in reading something is to not talk while reading. So come on in, go ahead, get your reading going. When you're done reading, please journal. This journal entry will be what is the summary of the article about, and what is the causes of the problem described in the journal. And I'd be totally okay if your journal entry was no more than 2 to 4 sentences at the most. Okay? So, guest teacher, if you do me a huge favor, go ahead and pause the video and give them the 3 to 5 minutes to read it and journal in their notebooks on the article. And when you're all done, by all means, come on back to the video. Hit play. Hit pause now, though. Awesome. So we're back. Hey, most of you probably went ahead and checked out the article. It was about fish. We're going to chat about this now. The article, the best way to view it, and before we do talk about it, here's your agenda. We've got news and a journal entry on fish, your lesson of the day. You're going to review a couple of jog-nog questions in class today. And then normally we'd finish the B1 Squishy Tables Lab, but without me here, I'm going to hold off and I'll finish it with you tomorrow. I do apologize. I know you want to find out how squishy these tables are. But instead, after the jog-nog questions, you guys are going to head on down to Computer Lab 134. And guest teacher, you want to use this key to get in to 134. It's right across from the library. The key will be on the keyboard right here. Excuse me. And students, whatever time is left over, and I can actually access this grade from home, but for every 4 quizzes you get completed today, by the end of today, and this includes any quizzes you've done already, every 4 quizzes will be equal to 1 Bulldog Buck. So keep that in mind. I'm going to be handing out the Bulldog Bucks tomorrow, but I'm going to be basing the scores tonight on Jognog when I go home. So you can maybe do a little more Jognogging at home. All right, so here we are. We're talking about our news. Hopefully your journal entry centers around the idea that there was thousands of fish found dead in the river on Monday. This is not the Westwood River. This is a canal down in New York. I'm hoping that most of you saw what was occurring, or actually read about what was occurring. And in your journal entry, I'm hoping that you discussed the causes of the fish kill. And give yourself credit if any of you mention in your article or in your journal entry the fact that the main reason for the fish kill was, 1, it's a canal, and so there was no fresh water coming in. 2, there was a super moon that actually brought the tide up even higher. And mind you, these are saltwater fish in a freshwater canal. They basically swam into the canal from a predator. The canal was closed shortly after they entered in. The people did not know they were in the canal. But overnight, because all these fish were stuck in such a small area, the amount of oxygen in the ocean, in the river, the canal, was just not sufficient enough to keep them alive, and unfortunately, they drowned. The fish literally drowned in the water. This is kind of alarming. It does happen sometimes in the fall, but not this late in the year. And part of that is due because at this point, the rivers and the waterways are starting to get cooler, which is actually a blessing in the world of physics, because cold water is actually able to hang on to more dissolved gases better than warmer water. And to prove this, I invite you sometime in June and July to take a little stroll by a lot of the rivers, the Westwood River, the Little River behind the building, and you will find very little activity in the world of life, mostly due to the fact that the water's warmed up so much that there's very little dissolved oxygen. And a lot of the organisms actually have to go and hide down underwater in the deeper holes, which is what a lot of fish do in the summertime. So, to give you a perspective on this, let's offer this. Here we go. And as you can tell, there's the end of the canal where it's all locked off and closed, and all the fish are coming to the surface. And quite a lot of fish are already pretty dead. And it's just one of those things where you could have walked across the river, the canal. Very, very unfortunate. Now, I bring this to you, attention-wise, because we're talking about chemistry. We're talking about gases. We're talking about compounds. And we can use this conversation as we move into talking about meteorology, which will be our next unit. So, next up here, I'm going to give everyone a chance here. Normally I'd ask you to use your clickers, but I'm going to hold off using the clickers today because the program does involve some experience. But I'd like everyone to look at this question on the screen. It says the suffix number 2 after, and it's in a dark black circle there. My question to you is, would it be A or B? 2 of that atom or 2 of that molecule? Guest teacher, if you could pause the video for 30 seconds, I'd appreciate it, and let the students talk, and then we'll come back and have a little chat about what the best answer is. Pause the video, please. All right, you guys hopefully figured out your best answer there. Looking at it, hopefully most of you noticed that the 2 in the front here is the coefficient for the whole compound. So this is saying 2 water molecules. So this 2 right down here is actually in reference to the letter in front of it, the H, which would indicate 2 of that atom. So hopefully you got A is the correct answer. All right, let's go to another question. Convection. It's either A, heat movement through a fluid, or heat movement through touch. Guest teacher or student that's back here at the computer, if you could pause the video, please. All right, I'm assuming you're done pausing the video, at which point I'm hoping that everyone here observed with Mr. Collier or Mrs. Palmer the ideas of conduction, convection, and radiation. When you made your coolers or you worked on your solar ovens, those 3 forms of heat and energy movement were discussed. As a review, as a reminder, convection has to do with heat movement through a fluid. So A is the correct answer. B down here, heat movement through a touch, that's conduction. And for those who want to remember the final one, radiation, that's heat movement through waves. Excellent. As a side note, the word fluid, please don't forget, fluid is not just liquids, it can also be gases. By definition, a fluid is anything that can occupy a space, so gases can do this. So keep in mind. All right, cool. Next question, number 3. Mixture. A, can't be separated into different parts, or B, can be separated into different parts. Guest teacher, please pause the video for 30 seconds. All right, you guys paused, you guys talked, you deliberated, you decided. Hopefully you came up with a similar answer. A mixture can be separated into different parts. Mixtures examples include a jar of nuts and bolts, or a container of salt and pepper. As fun as it would be to separate salt and pepper with tweezers, you could do it, and therefore a mixture is something that can be separated. Now, if I was to try and say A was the correct answer, I would have to change this word mixture to a couple of other possible options. One of them might be a compound. You could use a compound to define that. You can't separate compounds. Another one might be a pure substance. A pure substance, like a pure piece of copper. Only copper elements, atoms in that sample. You cannot separate it into different parts. It's all the same stuff. All right, let's go to another question. Number 4. We have a physical change, and your answers are either A, different matter comes about a physical change, or B, it's the same matter but just a different state. Guest teacher, please pause the video for 30 seconds. All right, you guys, you're back. This is a question we've been talking about so many times. I really do hope people feel comfortable explaining this. Please understand a physical change. If you do a physical change, it still can be brought back to the original form. You still have the same stuff here. So anything like water that can be frozen and then melted back to water again, that's the same matter, it's just a different state. And over here, this whole different matter, well, when you go from one thing to another, that's not a physical change. Instead, you would have to change the word physical to chemical. All right. Your final question of the day, number 5. Total energy. A, changes by position and speed, or B, stays the same. I'm going to give you a hint. With this one here, it does have to do with conservation of mass, conservation of matter, conservation of energy. All these things are hints to help you understand this. So, guest teacher, please, 30-second pause. Yikes. Here we are. All right, so you guys finished. You guys talked. You debated. What are people thinking? Best answer here? B. The energy stays the same. The total energy will be the same from beginning to end. It just might be in different forms. Like in this case here, we have potential energy, and down here we have, we have kinetic energy as it's moving, and we have potential energy down here. The energy is still the same total-wise. You can't create or destroy energy, so please, stop trying to do it. The best answer here is B, you guys. All right, so with that, you're done. And folks, I'd like you a huge favor. Please go and bring your article and put it back on the desk over by the door. Actually, from the video, it'd be this way. Put it back at the door and grab all your materials. If you'd like, you can leave from the computer lab. That'd probably be the smartest move. And guest teacher, please bring with you this key here. This gets you into 134. And when you're done getting in 134, could you return this key to the library? There's a little box over by the shelf right by the checkout area for these keys. And students, I will see you all Thursday. All right? Have a great day, folks. Enjoy yourself. Be good, be well. And remember, for every 4 quizzes, you get a Bulldog buck. Thanks a lot. Bye-bye.